Hello, assalamu alaikum, my dear friends. Welcome back to my YouTube channel. Today we will discuss our next topic, that is colloids. In the previous lecture we discussed about suspensions. Where we learned that a suspension is a heterogeneous mixture. A suspension is a heterogeneous mixture where solid particles do not dissolve in a liquid. Instead, they are spread throughout the bulk of a liquid. We also learned that the size of solute particles of a suspension is more than 1000 nanometer. More than 1000 nanometer. Now let's come to today's topic, that is colloids. A colloid is also a heterogeneous mixture like suspension. A colloid is also a heterogeneous mixture like suspension, though it seems to be homogeneous, but when it is observed through a high power microscope, it is found to be heterogeneous. A colloidal solution is a midway between a suspension and a true solution, because the size of solute particles of a colloidal solution is the intermediate between the suspension and a true solution. We already know that the size of solute particles of a true solution is less than 1 nanometer. True solution has particle size less than 1 nanometer. But as I already told you that a colloid or a colloidal solution has the particle size which is intermediate between a suspension and a true solution. That is, the size of solute particles of a colloid is bigger than a true solution and smaller than a suspension. To be more specific, the size of solute particles of a colloidal solution ranges from 1 nanometer to 1000 nanometer. The size of solute particles of a colloid ranges from 1 nanometer to 1000 nanometer. It is a midway. The particle size is intermediate between a true solution and a suspension. The examples of a colloidal solution are, the number one example is soap solution. The second one is starch solution. The third one is milk. As I already told you that a colloidal solution appears to be homogeneous, but when it is observed through a high power microscope, it is found to be heterogeneous. Likewise, milk appears to be homogeneous. When we see milk, it appears to be homogeneous. We can't distinctly see different components of milk. We can't see distinctly fat or protein or calcium or vitamins. But when milk is observed through a high power microscope, the fat particles present in the milk are suspended. That is why milk is heterogeneous, not a homogeneous mixture. The fourth one is ink. Ink is also heterogeneous. It is also a colloidal solution. The fifth one is blood. And another one is jelly. Let us make a soap solution so that we can get a practical view of a colloidal solution. For that, I have a beaker containing water. I will mix some soap powder with water in a beaker. This is a soap powder, and I will mix it in a water, and I will try to shake it. This is a colloidal solution. A mixture of soap and water is a colloidal solution. We can't see distinct particles or individual particles of soap. We can't see distinct layers of soap and water. If we kept this solution for some time, the soap particles will not settle down. And if we filter this solution, the whole solution will pass through the filter paper, showing that this solution cannot be separated by filtration. All these observations show that a soap solution may be a homogeneous solution. These are the characteristics of homogeneous solution. We don't have distinct layers. We can't see individual soap particles. We can't see individual water particles. So these observations show that a soap solution may be a homogeneous mixture, but the scattering of light by soap solution and the proper examination of soap solution under a high power microscope shows that a soap solution is not a homogeneous mixture. Instead, it is a heterogeneous mixture, because a true solution does not scatters the light, because the size of solute particles of a true solution is less than 1 nanometer. For this, we will do some practical activity, and before moving to the practical activity, we will make another solution that is a true solution. I have a beaker containing water. I will mix some salt with water in a beaker. And I will try to shake it. This is another solution. Now I have two types of mixtures. One is soap plus water and another is salt plus water. Now we will practically check whether a soap solution scatters a light or not. If a soap solution scatters a beam of light falling on them, then we can conclude it is not a true solution. It is a colloidal solution. And we will also check whether a mixture of salt and water scatters a light or not. If it does not scatters a beam of light, then we can conclude that this solution is a true solution. For this experiment, we need to go in a dark room. So let us go to the dark room and check for the light scattering experiment. Now, if a beam of light from a torch is put on a true solution, the path of light beam is invisible inside the solution. You can clearly see the light beam is invisible inside the solution. The beam of light can become visible only when the solute particles are big enough to reflect the light falling on them. Since the particles of a true solution do not scatter light, so we conclude that they must be very small. Now, if a beam of light is put on a colloidal solution, that is soap solution, the path of light beam is illuminated and becomes visible. You can clearly see the light beam is illuminated and is visible. The path of light beam becomes visible because the colloidal particles are big enough to scatter the light falling on them. So you see the practically that this soap solution scatters a beam of light. So it is not a true solution. It is a colloidal solution. And a true solution does not scatters a beam of light. Now this scattering of light by colloidal solution is called the Tyndall effect. The scattering of light scattering of light by colloidal solution is called Tyndall effect. The colloidal solution scatters the light because the particles of a colloidal solution are bigger than a true solution. So a colloidal solution, that is a soap solution, is not a true solution. Now let us discuss some properties of a colloidal solution. Number one, colloidal solution is heterogeneous, and though it appears to be homogeneous. Colloidal solution is heterogeneous, though it appears to be homogeneous. Number two, the size of colloidal particles are bigger than a true solution and smaller than a suspension. That is, the size of solute particles of a colloidal solution ranges from size of colloidal particles ranges from 1 nanometer to 1000 nanometer. The third point is the particles of a colloidal solution pass through a filter paper. So colloidal solutions cannot be separated by filtration. Cannot be separated by filtration. And the fourth point is colloidal solution scatters a beam of light. Scatters a beam of light. And the fifth one is colloidal solutions are quite stable. They are stable. They do not settle down in the bottom when we kept them for some time. Thank you. This was a little bit about a colloidal solution. Thank you.